Alrighty, ladies and gentlemen, welcome to a guide on using Ansys. Yeah, so let's get started. First things first, you have to launch Ansys using the Workbench 2022 R1 application thingy. Just a quick heads up, Ansys is pretty slow to load things in, so give it some time to do anything when you click. Or maybe my computer's just bad. Okay, so on the left here, we can go down to Fluid Flow Fluent. Double click on that, and then we're going to right click on geometry and import the SolidWorks design that we made earlier. I'll also make sure to use step files instead of SolidWorks files because Ansys doesn't like SolidWorks. Now we're going to right click onto geometry again, edit geometry in design modeler. Now it's going to launch design modeler and we just got to give it some more time. Just have to make sure I was actually recording this time. Cool. Alright, so now that it's all set up, all we got to do is click generate and it will actually add our import into it. First things first, we got to make sure that our actual airfoil is on the plane itself, because that makes it easier for it to do its calculations. As you can see, this airfoil is sadly not lined up perfectly, so we're going to create a new plane at the top left here. This new plane, we're going to change the type to from coordinates. Before we do that, let's actually change the units down to inches. And then go back to plane, right click, sections. We're going to make this 2.1 inches and then 1.22 inches. And that lines it up perfectly with the point of the leading edge. Next, we are going to generate, click new sketch, and this will create a new sketch on our newly made plane. We go down here to sketching on the bottom. We're going to create a rectangle and enclose our airfoil entirely. Then choose dimensions down here, and we're going to do length/distance. All you have to do is click the sides of the box and then click the center or the y-axis. And now we do the same thing with the top and the bottom of the box, and we're going to match them up with the x-axis. So the distance between the front bit of the airfoil and the airfoil itself has to be 5 times the length of the airfoil. So this airfoil is 12 inches, so we are going to make it 60 inches long. The back has to be 10 times longer than the airfoil, so again 132 inches here. 30 inches high for each of them. They say about 5 inches, but about 5 times more, but it doesn't really matter. Most of the space is going to be empty anyway. Just choose whatever number. And now we click generate. Now we extrude. And click apply right away because it's just going to apply the last geometry we made, the last sketch we made. We're going to change the operation from add material to add frozen and change the direction to both directions asymmetric. So just like we did with the box, it has to be 5 times longer than the airfoil itself. So the wingspan of this airfoil is 20 inches, so we are going to have 120 inches on one side and then 100 inches on the other. So now we have 5 times the distance between these. Yeah. Now we click generate once more. Our next step is to click create at the top left, go down to Boolean, change your operation from unite to subtract. Our target body is going to be the big box itself, and our tool body is going to be the little airfoil. So whenever you click on Ansys, it just clicks on whatever, like everything in line, so it pierces through everything. And on the bottom left here, you get to choose what it's actually selecting. So you're going to select the airfoil, click apply, and then generate. Now we have one last thing to do in the sketching itself. We are going to come over here, create a new sketch on the plane. This sketch, we're going to go to sketching, create another rectangle, and it's going to be a super tight rectangle on our airfoil itself. Then we click generate once more, extrude. The airfoil is again 20 inches. So we will first change it to frozen, and then change the direction to asymmetric. We're going to make it 25 inches in one direction, so it's a tiny bit longer than the airfoil itself, and then 5 inches in the other, and then generate. And now we're done with creating our mesh thing itself. Export, save project. Now we go, and I'm going to save it onto my homework thing. Boom, pow, beat of my heart. Change it to number 2, because whenever I save it over this one, it actually just has a stroke, so maybe that's the issue. Cool. Now we're going to right click mesh, edit. Nice, it loaded pretty fast this time. Cool. So just in case yours doesn't start up with a wireframe, you can click on at the top over here. You have 3 different selections. Well, I guess 4, but the 4th one isn't available. Always make sure to have it on wireframe, because I don't know how you would figure out things in this way. Cool. So we right click onto mesh. We're going to go into insert and then sizing. The first thing we're going to size is going to be, well, first you click on select bodies instead at the top here. We're going to be sizing the entire big box. That's going to be our geometry. The type, we're going to change it from element size to body of influence. The body of influence is going to be that tiny box we just made around the airfoil. Okay. That's take out, plop. Please stop being mean, Ansys. Every time I'm shuffling. Okay. Boom. Apply. There we go. We're going to change this to 0.5 meters as the element size, and we're going to add another mesh. Go back into insert sizing. This time we're going to do edge selection. From all the way right here, we're going to use the leading edge. And again, remember it spikes through, so we have to choose which one we actually want. And here we want the leading edge face. So you click it. Of course, Ansys is unresponsive because it doesn't like us. Okay. Try one more time. Boom. No? Cool. If it does this, just delete it and try again. I'm gonna go pow. Apply. There you go. Perfect. First try. And now their faces are geometry. Our element size is 0.6 meters for this. Now we create another mesh. Sizing. We are going to change it from face into edge. We're going to start with the leading edge of their first edge. We go boom, pow, apply that. Element size is going to be changed into number of divisions, and we're going to have 50 divisions for our leading edge. Change the behavior of it as well to hard from soft. And now we're going to go back and create another mesh. We're going to do the trailing edge lines next. And we're going to again change it from element size to number of divisions. 100 divisions is going to be these ones. And again, change it to hard. We're going to do one more. And now we're going to do the middle lines of our airfoil. And these are once again going to be changed to number of divisions. Oh, and 150. Behavior hard once more. Okay, so now you're done with your meshing bits, and you can click generate. And after like 30 seconds to a minute or whatever, you will be ready to do more stuffs. Also, the green bit that's highlighted is what it's currently working on. Now up here, we're going to click onto the face selection. We're going to select every face of this big box that we have. except for the back face right here. Then we're going to right click and then create name section. This will be our inlet. And then we're going to click on the box or the face in the back, create a new name section, outlet. And now we go into the y-axis view or whatever it's called. And we're going to change your select mode from single to box. And we're going to make a little box around the entire airfoil. And I'll select the airfoil, create the name section, name it airfoil. Okay. And now that you do this, you're done with this section. You close. There we go. Now we need to right click on mesh, click update. And there we go, it updated the mesh. Now we're going to right click setup, click edit. For this part, if you have, just leave it all. Never mind. Don't change anything here. Keep on waiting while it loads everything. Cool. Here's our beautiful box that represents air. Now, in setup, we're going to go down to models, and we're going to go down to viscous, right click it, edit. We're going to make sure our model is set to k omega 2 equations, and go down and change it to SST, and then click OK. Now we go into materials, we go into fluid, air, edit the air. Oh, I don't know what that pop-up was, but alright. Make sure our density and our viscosity is constant. Also, you only have to do this once because Ansys remembers your choices. And then you close. Next, we are going to change the inlet speed of the air. So like how fast is the stuff happening. So we go into boundary conditions, inlet, and then the inlet again. So right click and edit. For our thing, we're going to, how many meters per, I think it was 17 meters per second. That's how much 55 feet is. Or 55 feet per second is around 17. Sorry, that's what it was. But first, make sure the velocity specification method is set to magnitude and direction. And then all you have to change is velocity magnitude to 17. And apply. And then we close. Next, we are going to double click onto methods. And we'll bring up this section. The only thing we have to change here, or I guess the two things we have to change here, is our momentum, which has to be second order upwind. And we have to check mark this box that says pseudo time method. Once you're done with that, you could just go on to the next one, I guess. We go into here, so we're going to go into report definitions, right click it, edit, and we're going to add some definitions to report out for us. You click new, force, we're going to need drag and lift. So this is the drag coefficient for coef, or coef for coefficient. We're going to turn off report files and enter print the console, click OK. And we're going to do this 3 more times for the drag force and the lift coefficient and force. And then select the airfoil, turn off report file, enter print the console, OK. Click OK on airfoil again, turn off report file, enter console. And one more time. Boom. Ow. Okay. So now that we're done with this, you just click close. And now we have to change our monitors. Our residuals will, or you right click on residual, click edit. Change all of these to 1e to the -6. I like to copy and then just click paste every time because all of the the things there are completely different from each other. Like one is really far from E. I know it's not. I lied. I'm lazy. We're gonna change our number of iterations to 200. By the way, 1,000 just takes too long for me. And then you reach convergence a lot sooner. Although whenever you reach convergence, it stops either way, so you could keep it at 1,000 if you really want. Okay. Next, we go into convergence conditions, and we're going to create some conditions. We're going to add 4 of them. We will converge when all of these hit where they need, and we're going to choose our report definitions as every single one of the things we just made. Stop criterion, again, you know, the 1e to the -6. It was recommended to ignore the first 10 iterations by Rashid, and we will do so. And it's because the first 10 iterations look like an actual joke. I'll show you guys later on. And the iterations we're going to use are the 200 iterations. This is for the plots that it's actually gonna show us everything. And you just click OK. Cool, cool, cool. Now we will move on to I think we're all right. Yeah, all right, cool. Now we could just run calculations. Here, number of iterations is going to be 200 because that's how many iterations we're doing. You can do calculate. Now it's going to be like, hey, yo, wait a minute. Wait a minute. Well, once it loads, it's going to be like, hey, yo, wait a minute. Oh, these results are going to be funny. I think I forgot to change my report definitions from the names to the actual things. Cool. Yeah, it's going to be like, the solution must be initialized, please. And you're going to be like, yeah, go for it. And now you just wait for it to initialize. It takes a little while, but down here you can see how many iterations it's done. It's like, oh no, be careful. We didn't reach your convergence criteria in the first 10 tries. I wonder why, but yeah. So yeah, here's how it looks whenever it actually starts to do its calculations. Depending on how small your convergence criteria and your, I guess your iterations are, or how many iterations you have, the longer this will take. So I'll see you guys whenever it fully loads. Alrighty guys, welcome back. Calculations are finally complete. It actually didn't take that long. The log says it took there we go. It took 13 minutes and 52 seconds to complete the entire process, but now we have this. So at the top here you have different tabs to choose from. This shows all of them at once, or all of your residuals at once. As you can see, they got close to all being converged, but they're not perfection just yet. The more important ones are the drag coefficient, the drag force, and the coefficient of lift, and the coefficient of, the lift force. As you can see, our coefficient of drag with this setup was around 0.87, I guess, or 885, or 875, doesn't really matter. And the lift here, or the drag force, was not even half a newton, or I guess a little bit more than half a newton. The lift coefficient is 1.124, and the lift force, which is the yeah, I did exactly what I thought it did. I titled them different things, but I forgot to change what they were measuring. But you'd see that the lift force was kind of different as well. But yeah, that's how we do all of our checks to see which airfoil is the bestest. And I wish you all luck and a good night. See ya. Oh, wrong one.